So hello everyone. So today we are going to discuss preparation of alkanes. So many methods are there to prepare the alkanes. So today first one preparation method we are going to discuss. That one is from unsaturated hydrocarbons. So unsaturated hydrocarbons is double bond and triple bond, alkenes and alkynes. So alkenes and alkynes react with hydrogen in presence of finely divided catalyst like platinum, palladium or nickel catalyst to give alkanes. So addition of hydrogen. And addition of hydrogen means this process generally we can hydrogenation. Generally this process we can say that is the hydrogenation. Or addition of hydrogen, it is called reduction. So in presence of catalyst we are doing, so it is the catalytic reduction also. We can say it is the catalytic reduction. Catalytic reduction. So alkenes and alkynes react with hydrogen in presence of some catalyst like platinum, palladium, nickel, it will give the alkanes. So platinum or palladium catalyze the reaction at room temperature. So in room temperature reaction will proceed. If we take the nickel catalyst, so it requires more temperature and pressure. It requires more temperature and pressure. So platinum, palladium if you use means room temperature is enough. If nickel means more temperature is required to catalyze this reaction. So alkenes reacts with hydrogen, so it will form alkane. This is the catalytic reduction because addition of hydrogen is called reduction, so it is the catalytic reduction. And if we take alkyne, it will react with 2 moles of hydrogen because to break 1 pi bond 1 hydrogen is required. To break 2 pi bonds 2 moles of hydrogen is required, so it can form alkane. So here you can use platinum or palladium. Platinum or palladium. For this, so room temperature is enough for these reactions because platinum palladium catalyze the reaction at room temperature. But if we take nickel catalyst, if we take the nickel catalyst, so it required 200 to 300 degrees Celsius. So if we take the nickel catalyst, it will take 200 to 300 degrees to convert alkane. And this process is called, this reaction name is called Sabatier and Sanderson's equation. This reaction is called Sabatier and Sanderson equation. No sir, I will use nickel, but I will use only room temperature. How it will react means, so if you, in room temperature in presence of nickel catalyst you find the reaction means just you can take the Raney nickel. So what is the Raney nickel? So alkenes reacts with hydrogen in presence of Raney nickel. So Raney nickel means reaction occurs at room temperature. High temperature is no need. It will convert into alkane easily. So what is the rann nickel means? So rann nickel is the alloy of nickel and aluminum in NaOH, sodium hydroxide. Nickel and aluminum in sodium hydroxide. This is called a rann nickel. So if you take the rann nickel, so room temperature is enough. If you take the normal nickel, 200 to 300 is required. So finally, alkenes and alkynes react with hydrogen, it will give alkane. So if you see the mechanism, so if you take, it is the platinum catalyst. So first, hydrogen gas will absorbed on the metal surface. Then alkane. So I will take one alkane, one alkene, that is CH, C double bond C, hydrogen and hydrogen. So this alkene. So first hydrogen gas absorbed on the surface of the metal, then alkene will come and it will bombard, hit the hydrogen molecule. So that time it will form the transition state between the hydrogen and carbon, like this. Then slowly these old bonds, it will break and new bonds forms. So between the hydrogen carbon bond will break, and between the carbon and hydrogen bond will form. So finally hydrogen C and hydrogen, single bond C, hydrogen. So here bond will break, then this bond will form, hydrogen and hydrogen bond will form. So like that it will form the alkane, and then as usual catalyst will come out. So like that alkenes convert into alkanes and alkynes convert into alkanes. So it is the, if it is like a process, this process is called adsorption process. Adsorption, because so hydrogen gas is adsorbed on the platinum surface, that's why it is called adsorption process. And during this reaction energy is released, so it is a exothermic reaction. It is exothermic reaction, that is delta H is negative, exothermic reaction. And here there is no intermediate is formed, just transition state is formed, cyclic transition state is formed. And methane cannot be prepared by this method. Methane cannot be prepared by this method, because if you take alkene and alkynes, the minimum number of carbons in alkenes and alkynes are 2. So then methane have only 1 carbon. So alkynes use, if you use alkene and alkyne, methane cannot be prepared. And this addition is syn addition. This addition is syn addition, meaning, so here both the hydrogens will attack on the, will add on the same side. So if 2 hydrogens attack on the same side, that is called syn addition. 1 hydrogen upside, 1 hydrogen downside means that is called anti addition. So it is the syn addition. Syn addition. And if we go to the reactivity wise, alkynes are more reactive than the alkenes. This is the reactivity order. Why? Because this is the syn addition. So the two hydrogens will attack on the same side. So wherever less steric hindrance, that side it will attack. So if you take alkynes, alkyne is the linear shape and alkenes are trigonal planar. So if you take the linear molecule like this, linearly is there, so two sides hydrogen will attack easily. That's why alkynes are more reactive than the alkenes. So if you see the reaction, one reaction if you see means like this, one double bond and one triple bond is there. Then if it will react with the hydrogen in presence of platinum, so they didn't mention anything means it is the excess reagent. So more number of hydrogens are there. So it can break the all the pi bonds. 3 pi bonds it will break and it will give the alkane. It will give the alkane. And then sometimes they will mention like this, hydrogen in presence of platinum at one equivalent they mentioned. One equivalent means only one hydrogen, means number of moles are 1 mole. 1 mole means it can break only 1 pi bond. So there is a double bond, there is a triple bond. So which bond will break? So already I discussed it before. So alkynes are more reactive due to linear shape. So first alkynes, one bond will break. Like this product will form. Okay, now this is the reaction. And here important thing. So if you have one double bond, one triple bond, first triple bond will break, then it comes to double bond. Then if two double bonds are there, which double bond will break first? So that is a regioselectivity. Regioselectivity, important one more. Which double bond will break first? Means for suppose like this, two double bonds are there, and already I discussed it. Generally if it is mentioned hydrogen in presence of platinum or palladium like this, so number of hydrogens they didn't mention anything, so it can break all the pi bonds. So break all the pi bonds and like this product is formed. Then hydrogen in presence of platinum at one equivalent then mentioned, means one hydrogen is there, means this pi bond will break or this pi bond will break. This is the regioselectivity, means less reactive alkene will be reduced first. Out of these two pi bonds, I mean out of these two alkene, which alkene is less stable, that will be reduced first. So how to check the stability of alkene? So stability of alkene is directly proportional to number of hyperconjugative structures. So per suppose, so hyperconjugations it will come in the GOC chapter. So there we will discuss properly. Now, so if you take this pi bond, for this pi bond, it is sp2 carbon. So sp2 carbon, attached carbon is sp3 carbon. That sp3 carbon having the hydrogen, that is called alpha hydrogen. So more number of alpha hydrogens. So number of alpha hydrogens. So more number of alpha hydrogens, that is the more hyperconjugated structures, more stable. So here 3 alpha hydrogens, and this side if you take means 2 alpha hydrogens, this side 2 alpha hydrogens. So total 6 plus 4, 10 alpha hydrogens. So this double bond having 10 hyperconjugative structures. So if you take this pi bond, so it have 2 and 2, 4 alpha hydrogens. So this pi bond have 4 hyperconjugate structures. So it can break this pi bond. Lower number of alpha hydrogens is the least stable alpha hydrogens, least stable alkene. So it will break first. This is the regio selectivity. Like that, if we take one more example, if you take this molecule, so here if you take hydrogen in presence of platinum, one equivalent, then which bond will be reduced first? So for this pi bond, first you can count the alpha hydrogens. So here 2 alpha hydrogens, here 2 alpha hydrogens, here 3 alpha hydrogens. Total for this pi bond 7 alpha hydrogens, so it should form 7 hyperconjugate structures. If we take this pi bond, here 3 alpha hydrogens, here 2 alpha hydrogens. Total it shows 5 alpha hydrogens, so it will show the 5 hyperconjugate structures. So it will be least hyperconjugate structure, so it should be least stable, so this bond will be reduced first. So then the product is like this. So this pi bond will break easily because least stable double bond, least stable alkene due to less number of hyperconjugative structures. This is called regioselectivity. If you go to chemioselectivity, mean for suppose keto group and alkene group, both it is there, then hydrogen in presence of platinum at 1 equivalent is given, then this pi bond will break or this pi bond will break. So this is called chemioselectivity, means compared to this all groups, aldehyde group, keto group, or carboxylic acid group, or ester group, compared to these all groups, alkene is more reactive. So alkene will be reduced first. So this double bond, nothing will happen. Here they didn't mention this equivalent, means this double bond also will break. So it will form the alcohol. Got it, ma? So this is the preparation method of alkane, first method. So if you see it, first one. So from uncharged hydrocarbons, so it is called a hydrogenation process, a catalytic reduction, because addition of hydrogen is called a reduction. So in presence of catalyst, so it should be catalytic reduction. So if you use platinum palladium, room temperature is enough. If you use the nickel, high temperature is required. So alkenes and alkynes in presence of hydrogen, it form the alkanes. Alkenes now 1 hydrogen is enough. If you take alkynes, 2 moles of hydrogen is required. And if you take the nickel, 200 to 300 temperature is required. If you conduct the room temperature at nickel catalyst, you can take it as the Rann nickel. So Rann nickel means alloy of nickel and aluminum in NaOH. And if you see the mechanism, this is the mechanism. It is the absorption process and reaction is exothermic. Methane cannot be provided by this method. This addition is called syn addition. Both the hydrogens will add same the side. And reaction wise, alkynes are more reactive than the alkenes due to their shape. And so already we discussed, if one double bond, one triple bond is there, first triple bond will break. If both 2 double bonds are there, which double bond is least alpha hydrogens, means least hyperconjugate structures, least stable alkene, that alkene will be reduced first. Then if any other functional groups are there, like ketone, aldehyde, so ketone, aldehydes, that groups are least reactive than the double bond alkene. So double bond alkenes are more reactive, so first double bond will break, then it will break the C double bond group. Thank you.